So let us discuss non-homogeneous higher order linear differential equations, and I'm not going to write again and again, let's say with constant coefficients. And the differential equation is in this form: f of d operated on y equals some capital F of x. You know very well this f of d is any operator in the form of d. It can be some second order or third order or fourth order, and this everything is operated on y, and the right hand side is f of x. And right hand side is not zero, hence we call it non-homogeneous. And we have different cases for this. Like this right hand side can be an exponential function, right hand side can be like a polynomial, and it can be a sinusoidal function like sin x or cos x, or it can be some other trigonometric function or logarithmic function. So there are some working rules to find out the particular integral when we have some defined structure for that. Like when this f of x is exponential, when this is polynomial and sinusoidal, then we have some working rules for that. First of all, we are going to discuss those. Then the method of undetermined coefficients will help us with some forms, not all. Like it can help us again with sinusoidal, exponential and polynomial. But when this right hand side is some sort of tangent function like tan x or log x, then those working rules and undetermined coefficients will not help us. Then we'll take help from variation of parameters. So we have some defined forms for everything. So let us discuss how to find out the particular integral in these different cases. So there are some working rules for these. First, number one, when your f of x is an exponential function, but the power of exponential should be a linear function in x. This is the condition. It should not be e raised to x square or e raised to x cube. So in this case, what you can do, you just take this f of d on this side, f of d operated on y equals e raised to x. You take f of d here, so your particular integral, what we call yp, would be 1 over f of d e raised to ax. Now the problem is, we want a solution which we call yp, and this solution involves this d. So we have to just remove d, and at the place of d we have to put this a. So this is the first working rule. When your right hand side is e raised to x, your yp is going to be only this. And there is a proof behind that, but we are not going to discuss that. When your right hand side is of this form, you are finding yp, and this is the method for that. What is the problem with this one?
f of a should not be 0.
Yes. What happens when f of a is 0? It's going to be undefined. Then what should be done?
There must be a restriction.
And the restriction is that f of a should not be equal to 0. What if this f of a is 0? Then what is going to be yp? Then you don't evaluate f at a, you evaluate f prime. F prime at a. But since you are evaluating f prime, then you have to compensate the things. And for the compensation, you just multiply x. This is the compensation. And what is the condition here? Here f of a is 0, but f prime of a should not be equal to 0. But what if f prime of a is 0? Again we have to extend things. I was having that idea. Okay, so this is yp, but the condition is that this should not be 0. If this thing is 0, then your yp would be f of a should be replaced with f prime of a.
Prime of a.
But if you are doing some replacements, then you have to do some compensation, and the compensation is x.
X
Again, here this f prime of a should not be
should
equal
not
to
be
0.
0.
And if this is 0, again we have to do something else. Then we can extend this idea to yp equals
x power n
x,
X.
n minus
but
1.
not this, only the next condition, and we'll write it so on. X square 1 over
Double dash
f double prime of a e raised to
X
ax, and the condition is here f of a
is equal to 0.
is 0,
F dash of a
f prime of a is 0,
but
f double prime of a
no, it should not be 0.
should not be equal to 0.
Okay, sir.
This is the condition. And if this is going to be 0, then we'll extend the idea towards triple prime and so on. Okay, let us take the same equation and extend our idea that what can we do in this case. Let us assume my equation is of this form. Clearly it is non-homogeous.
Non-homogeneous.
This is a non-homogeneous differential equation. To solve it, the first thing is that you will solve corresponding homogeneous equation. An homogeneous equation is d2 plus 4d plus 5 y equals 0.
0.
And the solution of this homogeneous equation is this, what we have done so far.
Yes, sir.
And we call this yc.
C.
And for this, we also need yp,
By
and the sum of yc and yp is what we call the
linear
general solution,
General.
or what?
Yes, sir.
Let us find yp in this case. Since you can see that the right hand side is f of x,
Yes, sir.
and the rule 1 says that this f of x is exponential, and we have same exponential here. We have the same thing. So how can we do this thing?
Put
Yp is simply
yes, sir.
1 over
F of a.
f of a
A
e raised to
minus
ax. And let me write what is our f of d. Our f of d is this:
D square.
d square plus 4d plus 5. d square plus 4d plus
5.
5. Just evaluate f of a.
A.
But in our case a is
Minus 2.
minus 2.
2
So minus 2 square.
square.
4 times minus 2 plus
5.
5. What's going to be answer?
1, sir. 1.
1.
Yes, sir.
So yp is going to be 1 over f of minus 2
Minus 2.
e raised to minus 2x. Since this answer is
1.
1, so it's going to be e raised to
Minus 2x.
minus 2x. This is our yp.
Particular.
So yp is simply 1 over f of minus 2
2.
times this. F of minus 2 is 1.
1.
So we are only left with e raised to minus 2x.
Minus 2x.
This is our yp. And when we sum yc and yp, it's going to be the general solution.
Yes, sir.
And the thing is that if you take yc, it will only satisfy this homogeneous equation.
Okay.
Because you put here and you solve, you will get 0.
0.
If you put yc in this one,
It will not.
satisfy this equation, because the left hand side is going to be 0
Yes,
and
sir.
you have right hand side e raised to minus 2x. But this particular integral
Also.
will not satisfy this,
Yes, sir.
but this particular integral will satisfy
Only.
non-homogeneous equation. You put just y and you differentiate 2 times once and multiply 5, simplify, your answer will be this.
Yes, sir.
But the sum of these two will satisfy this whole equation, what we call the general solution. Y is equal to yc plus yp.
YP.
Now, afterwards, we'll not be interested in yc, only we'll find yp, because it's very easy to find out yc. So it's e raised to minus 2x, c1 cos x plus c2 sin x,
Plus
and plus e raised to
minus 2x.
minus 2x. And one thing else that I should mention in the beginning, that I can readily identify that f of minus 2 will never be 0 in this case. In this case, the condition is your yc
Is exponential.
yc involves no function of this form independently. If your yc involves e raised to minus 2x, obviously this f of minus 2 is going to be 0. Then you will apply another condition of f prime.
Yes.
You can see the first function is e raised to minus 2x times cos x,
Cos x,
and the second one is e raised to minus 2x times
sin x.
sin x. Suppose your yc was this one, and c1 e raised to minus 2x, c2 e raised to 2x. Then you can see your yc involves e raised to minus 2x, and your right hand side is also same.
Yes, sir.
Then this f of minus 2 would have been 0. Then what you might have done, you have substituted here prime and here x. Then your solution would be x e raised to minus 2x times some constant, whatever it is.
Yes, sir.
Then you can see why this happens, because we want something to be linearly independent than this one. That is why this thing happens.
Yes, sir.
And again we will see different examples in this case. Okay, so let us go ahead with the another case. Now the second case is when your f of x is sin x or cos x with some coefficient. So we write that, or it is okay with this. Okay, so right hand side is sin x or cos x, but it should better be sin ax, cos x, because the coefficients can be different. Sin ax or cos x. So you know very well yp is simply 1 over f of d, and then you have sin ax. I am not writing cos x because the method for both of these is same. Then what you do, you just write your f of d in this form, f of d square, and you replace d square by minus a square sin ax. This is how we solve it for yp. You write your f of d in the form of d squares only, and you will think that okay, d power 4 and d square can be written in d square, but how about d cube and d when they are single? So we'll see in an example that what can we do in that case. So d square is replaced by minus a, and what is this a? This a is this coefficient a square, and you can see that this square is only the power of a,
Power of a, yes, sir.
and minus is outside that.
It's outside.
Okay, so let us discuss one example in this case.
सर इसमें कंफ्यूजन के को क्लिक पे किए जो क्वेश्चन एक्सपोनेंशियल फंक्शन है इनमें f of a b 0 से 3 है f prime of a b 0 से 3 है f double prime of a b up to n थर्ड सजा जेकने 0 थी चाहे डी पॉसिबिलिटी है या एटलीस्ट वन सॉल्यूशन मस्ट बी
If the order of your differential equation is n, then you will not solve nth order differential equation. The order would be either 2 or 3 or 4 or 5.
ओके
Okay. Then at most, if the order is n, then at most nth derivative would be 0. Then the next would not be 0. Because you will not solve differential equations of infinite order. It's not possible. If you are solving that, then it's not possible. But the value of n should be fixed. Then up to n, it is possible that it might happen, but after that, it will never be 0. Example, only we are interested in finding out yp. So example is d square minus 5d plus 6 operated on y equals sin 3x. how to find out yp in this case? The formula for yp is this one. So we'll take this thing and divide on this side. So our yp is 1 over d square minus 5d plus 6 sine 3x. What is the value of a?
3.
The value of a is 3.
3.
What you will do, at the place of d square you will put minus 3 square. At the place of d square. And d will be left as it is. So this d square becomes minus 3 square, which is going to be minus 9. So our yp would be 1 over minus 9 minus 5d plus 6 sine 3x. Now it will be yp equals 1 over minus 3 minus 5d, or minus common 5d plus 3 and sine 3x. Okay, now the problem is in sinusoidal functions only we replace d square with minus a square. It means if you have some odd powers, then they will be left same. Like if the power is d cube, then you can write this one as d square times d. At the place of d square you put minus a square. Like in this case it would be minus 9d. So if you put d square and d cube in this way, then at the end you are left with the single power of d. And now what you need to do, you have to convert this d into d square. And what is the way for that? Minus 5d plus 3, we only what we call rationalize or apply some methods like this to make it d square. Sine 3x, then this becomes minus 5d minus 3. This would be 25d square minus 9 sine 3x. Then you put d square is equal to minus a square and you will solve the remaining problem easily. So again, d square would be equal to minus 3 square. So this becomes minus 5d minus 3. This would be minus 9 and minus 9 would be I think common, 25 plus 1. Is it okay? Minus can be cancelled out and this is 1 over whatever this number is, 25 plus 1, 26. 26 now times 9 is 260, 240, 236. Okay. Then you apply 5d minus 3 on sine 3x. And what happens that 5 and d of sine 3x means the derivative of sine 3x minus 3 times sine 3x. 234? Yes, 234. 25 plus 1, 26. Yes. 1 over 234. And derivative of sine 3x is cos 3x times 3. So 15 cos 3x minus 3 sine 3x. This is what we call yp. Sometimes in sinusoidal it's going to be a bit difficult, otherwise it's not that one. So this is when you have the right hand side to be sine x or cos x. Now what is the third case? Exponential and then sinusoidal and then it's a polynomial. Then there are going to be the combinations of these, like exponential with polynomial, exponential with sinusoidal, and so on. So let us discuss the next case. So, sir, d means derivative. Derivative of sine is cos, and the derivative of angle is 3. So this is 15 cos dx. D only means derivative here. So third case is what we call f of x is some x raised to k. Let's assume k is n. Okay, so dealing with this one is again very easy because we only should know binomial expansion or the related things, then everything is very easy. So you have f of d operated on y equals x power k. So yp is going to be 1 over f of d and x raised to k. Then yp would be f of d whole power minus 1 x raised to k. You just expand power minus 1 with the help of binomial theorem and you operate on x power k. But the problem is, since the power is negative, this expansion will contain infinite terms. But we will only consider those powers up to the order of k, because you know very well, if you have x raised to k and you differentiate it k times, it's okay. But I think if you differentiate k plus 1 times, this is going to be 0. Because what is the power? 2. First derivative is 2x, second derivative is 2. Up to 2 derivatives you are okay. Third derivative would be 0. So since these are polynomials, but the condition that you have to keep in your mind, you have to expand this into increasing powers of d. F of d should be expanded in the increasing powers of d, like d power 1, d power 2 and so on. Then it's going to be very easy. Otherwise, we are unable to solve this thing. So let us take an example in this case. Example is d square minus 4d plus 5 y equals, let's say, x square. It's going to be very simple. So yp is going to be 1 over d square minus 4d plus 5 x square. Now how can I expand this particular thing when taking the numerator into the increasing powers of x? The first thing is that I have to take this 5 common and then rearrange the things. It means writing this thing first. That would be 1 plus d square minus 4d over 5. Is it okay?
Yes.
And then taking this whole thing into the numerator, I have 1 plus d square minus 4d over 5 whole power minus 1 x square. Now how to expand this thing into increasing powers? We know very well, if we have this thing 1 plus x power minus 1, it would be 1 minus x plus x square minus x cube. Is it okay?
Plus minus, okay.
1 minus x plus x square and so on. So we have to expand this thing in this way. So 1 over 5, this becomes 1 minus d square minus 4d over 5 plus the square of this. I am assuming this whole thing to be x. And if we square this one,
4.
this would be d power 4. This would be
d cube
square this one.
square.
The square of d is d square.
It's only a square. Multiply. 16 d square.
It means I don't want d cube, d power 4 and so on. I want only up to d square. Will this term contain d square?
Yes.
No.
This will.
Yes, last.
This will, the last one.
Last one.
So
16.
d square minus 4d over 5 whole square, and I am going to neglect the remaining terms times x square. So 1 over 5, 1 minus d square over 5 minus into minus plus 4d over 5 plus. Why am I going to neglect? Because the third derivative, fourth derivative and so on of these will going to be 0. So what I need to do,
16.
this is going to be ignored because d square whole square would be 4. Ignore the product of these two, ignored only this one.
16.
So 16 d square over
25.
25. So just we need to solve these things. So 1 over 5,
X square.
1 multiplied by x square, d square operated on x square.
2x minus 2 upon 5.
Yes. D square means the second derivative of x square. The first derivative is 2x, the second derivative is 2. So this is going to be minus 2 over 5 plus d means the first derivative.
2x.
That would be 2x. 2x times 4,
8x.
8x over 5. D square means second derivative is going to be 2.
32
So 32 by 25. Then we just need to simplify this. That's going to be our answer. So you can see that this is of this form: ax square plus bx plus c. This will be quadratic. And in undetermined coefficients, we have to assume this solution, and then we have to find out the values of a, b, c. Put there, then that would be our solution in the method of undetermined coefficients. So what is the next case after third one? Combination of exponential with sinusoidal, exponential with polynomial, and so on. And there can be the combination of these three as well. So the fourth case is your f of x is, let's say, some exponential times any function. And what do I mean by this? This can be exponential itself, this can be sinusoidal, this can be polynomial as well. So your yp would be 1 over f of d. So how to deal with this case? When you have product of two functions, if you have only exponential, what to be done? Just replace d by a, you are done. If you have only like this one, it is sinusoidal, then d square is going to be minus a square. If it is polynomial, then you have to do this idea. But now in this one, what we have to do, we have to shift the exponential. The idea is you can take this exponential out of this, and the idea is you can't do this. You have to compensate. Compensation. Then what you need to do, you just replace this d by d plus this a. You're done. Now there is no any role of exponential. Only you will deal with this idea. This can be trigonometric, this can be polynomial or anything. You have to deal with this idea.
exponential function हो जाए ना सीधा ही
What if both are not that?
कोई सा को
उन्हें देते हैं ना सान पर पहले सवाल ये हुआ exponential times polynomial. Okay. Exponential times sin x cos x. Okay, there's no problem. Now the question is like sin x multiplied by polynomial. Because we have these cases only. We don't have any other case. We have these cases. How to deal with this one? X power k times sin ax.
He got 4 case only exponential.
Exponential multiplied by something. It can be x power k, it can be sin x cos x. Then what do? You shift the exponential. Now there is no any role of exponential. Then you have to solve this. And if this is sinusoidal, you know very well how to do it. If this is x, how to do it, you know very well. Just replace d by d plus a. But how about this case? When you have like sin or cos multiplied by any polynomial. In this case, can you write this one as in this way? What is this e raised to I ax? e raised to I ax by Euler's theorem, it is going to be cos ax plus I sin ax. What if I find the imaginary part of both sides? What is the imaginary part of this side? Imaginary. Sin x is imaginary is this one. So can I write sin x as the imaginary part of this? I can write, because e power I ax by Euler's theorem is cos ax, and then this iota sin ax. If I take imaginary part, this is the opposite. And we know very well the sin ax is going to be then equal to the imaginary part of this. So I am writing sin x as the imaginary part of this guy. Now you only solve this thing. X power k e raised to I ax, and then you take the imaginary part. Now what do you have? Exponential, polynomial. Can you apply the same case? Same. You solve this. At the end you will get two solutions. One is real, one is imaginary. Take imaginary. If this is cos, then take real part. That's all. So you can apply the same. This is what we call the shift operator. You can apply the shift operator here as well, because this is exponential. Once you apply shift operator, you are done. So these are some cases how we find the particular integral with the help of these formulas. We can do these examples as well, but they will consume a lot of time. So we are directly moving towards something else.